And there we go. All right, so we're talking about acceleration today. Like I said, a lot of this will be a review for you guys. You already know. So acceleration, the definition, obviously, that's the equation written out, right? Everybody with me? That's the equation written out. It is the change in velocity over time. Remember, final minus initial. That's what change means. That's the definition. The units, ms squared. I know this is a lot of review. We just did this. In Moodle, you can put either one of these answers. It'll count either one correct. I don't care which one. Okay? This one's actually probably more precise because it's telling you to raise it to that power. That's what the caret means right here. But I've programmed it into Moodle where it should take both those answers. Okay? So when I ask you for the SI units for acceleration in Moodle, you can put either of those. It should take it. If it doesn't, take a screenshot, email me. I'll fix it. Okay? It shouldn't, though. The symbol for the variable acceleration is A, or the acceleration average, or A. Probably just going to use A here, okay? You can use either one. The nice thing is on your reference sheet, you don't have to memorize that. On your reference sheet you're going to be using, has every variable we use this entire year, right here. Okay, so you have that lowercase v is velocity, capital V is voltage. That's why it's kind of important to understand the difference between those two. Okay, we will eventually in the second semester. All right. Now, think about this at your table. Right? Think if it's a vector or scalar quantity. Think about that. Right? Is acceleration vector or scalar? You have a 50-50 shot. Okay. So it's a vector quantity. Does anybody know why it's a vector quantity?
Because it can be negative.
Because it can be negative. But why? Why can it be negative?
You can accelerate slowly.
Yes. Yeah, but why can it be negative? You're right. You can accelerate slower. That can be negative. Velocity is a vector, right? You with me? Yeah, it's direction, right? Exactly. So if velocity can be negative, acceleration can be negative. You guys are both right. You got the idea, right? So if velocity can be negative, well then so can acceleration. Because a vector is in this calculation. Can time be negative?
No.
Never. Okay? If you ever get a negative time, you've done something wrong in your problem. It's a great way to double check. Okay? So it is a vector quantity. The direction matters. Vector, velocity is a vector, acceleration is a vector. Okay? This will help you on problem sets. Anytime you work a physics problem, you want to step back and think, does this answer make sense? Okay? You can do that a lot in physics, which is nice. Sometimes in math, you get that number, like, I guess that number is right or wrong. I have no idea. Right? But now you can kind of use your common sense and think about, does that make sense? So guys, if you are speeding up, right, you are going to have a positive acceleration. Because remember, it's final minus initial. If I'm going 10 miles an hour and I started at 0, my change is going to be positive, delta V. Okay? So if you have a positive acceleration, you're speeding up. This should make sense, guys. If you're slowing down, you should have a negative acceleration or deceleration. Our textbooks want you to use negative acceleration, but you're going to see the word to decelerate, right? Deceleration, that means to slow down. So, if you're something slowing down, your acceleration should be negative. If something's speeding up, your acceleration should be positive. That's a great way to check at the end. Okay, the thing was speeding up, so my acceleration's negative. I did something wrong. I probably flipped stuff. Okay? So, let me explain how this works. Okay? So gravity is actually 9.8 meters per second squared. We're going to round that up to 10 meters per second squared. Okay? Assuming no air resistance, right? What we're going to see, guys, is so time, velocity, and acceleration. After 1 second, My velocity is 10 meters per second. It's just 10 meters per second. My acceleration is 10 meters per second squared. After 2 seconds, my velocity is 20 meters per second. But notice this is staying the same. Final minus initial is 10. Final minus initial is 1. So it's going to be 10 divided by 1. Because remember, acceleration equals delta V over delta T. Okay? So when I say to accelerate, my acceleration is staying constant, but I'm still speeding up. That's what accelerate means. So if after 3 seconds, I'm going 30 meters per second. Well, guess what? 30 minus 20 is 10. 3 minus 2 is 1. 10 divided by 1 is 10.
Wait, isn't it final minus initial?
This is my final velocity. This is my initial velocity. Final is the furthest one you've done.
But wouldn't the initial be 10?
So, if we did, from the last point, from that last point there. You with me on that?
Oh.
From that last point. That's what I was just doing from the last point there. Okay? So, if you did do it from that point, right, that would give you, well, let's do it. So, let's say 30 minus 10 equals 20, right? Divide by 3 minus 1 equals 2, which would equal the same thing. You see what I'm saying? Yeah? So it doesn't matter. I can start from there or there. I'm glad you asked that question. Okay? So notice, this is a common misconception for students. If my acceleration stays constant, my velocity does not stay constant. If my acceleration stays the same here, but over time, this is still going to be going up. Because we're getting faster and 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 faster. So how does this work algebraically? Now, if what I'm doing right now doesn't make sense algebraically, don't freak out. These are my units, right? So velocities units are meters per second. Times unit is seconds. I just realized this is probably off the chart. Let me write this down real quick for the video. All right, I realize that that's not even in screen. So velocity is here, times units here. Okay. When you do that, when you solve that algebraically, it's the same thing as this. Times 1 over s. Okay. That is why my units for acceleration are, after every second, it changes the velocity. Okay, after every second, the velocity changes, either positive or negative. Okay, after positive or negative. All right.